Today's video is going to discuss Chapter 3.6, proportional and non-proportional relationships. So think about what you know about these two words, proportional, and then obviously the opposite of that would be non-proportional, and we're going to kind of use them today in math. So talking about proportional relationships, there are basically three key elements of a mathematical proportional relationship. So you may want to think about writing these down in your notes. The first is that the graph is going to pass through the point 0, 0. It's going to pass through the origin. The second is that the equation can be written, or it's an equation of, and I'm writing it in function notation, which is why it says f of x instead of y. But keep in mind, f of x and y are the exact same thing. So it has to be an equation of f of x equals kx, or if you remember y equals kx, that was our direct variation. So it's a direct variation. And if you take the first value for the first point, and you take the x value and you put it over the y value, and then you take the second point and you put the x value over the y value, and you take the third point and you put the x value over the y value, these will be equivalent fractions. I'm going to show you exactly what this looks like in just a moment. So basically it goes through the origin, it is a direct variation, and we can write it in function notation. So we're going to practice function notation today, writing f of x instead of y, and then the fractions are equivalent. Keep in mind, you actually could flip these and go y1 over x1, y2 over x2, y3 over x3, and I will show you that as well in just a moment. So let's take a look at the first problem. Now keep in mind that in class tomorrow, a lot of these problems are going to be written as story problems, but once you get the table, looks like this: x, 1, 2, 3, 4, and then y is 45, 90, 135, 180. So the first thing we want to think about is the pattern. Okay? And so the idea is, are these going up by a constant rate? And same here, are these going up by a constant rate? And since the x's are going up by 1, the y's are going up by 45. Hopefully we see that. And so the idea is that the change in y is 45 and the change in x is 1. So my constant rate of change is 45 over 1. And like we've talked about, constant rate of change, the direct variation, the slope are all the same thing. So essentially the slope of this thing is 45, right? Now, I want to show you how we figure out if this is a proportional relationship. So for this particular relationship, we could not necessarily determine that the graph goes through 0. However, if you think about taking this back 1, so if you were to go back 1, this would go down 1 to 0, this would go down 45, 0, and I would have 0, 0. So this is going to pass through 0, 0. But let's pretend for a second you don't necessarily see that. The next question is, can it be written in the form of f of x equals kx? So, if you think of it, f of x would equal the change, which is the constant rate of change, by k, times x. So the question is, does that formula work? So if I put a 1 in here for x, 45 times 1 is 45, gets me there. If I take a 2 and I substitute it in here for x, 45 times 2 is 90. Take a 3, substitute it in here for x, 45 times 3 is 135. Right? And then obviously it goes so on. So this formula works, which means it can be written in the equation of f of x equals kx. So let's look at the third to make sure it satisfies the third. x1 over y1 equals x2 over y2 equals x3 over y3. So that would mean that I'm going to do x1 over y1, so that's 1 over 45 equals 2 over 90 equals 3 over 135, and you can kind of keep going if you wanted to. Well, if I reduce this, this is 1 over 45. Divide the top and the bottom by 2. This is 1 over 45. Divide the top and the bottom by 3, and this is 1 over 45. So these all are equivalent. You also could do this the other way. So you could have gone 45 over 1. And for some of you, it may be easier to see it when you put the y on top, but that means I need to take these and I have to flip them. 45 over 1, 90 over 2, 135 over 3. And then when I reduce this, this becomes 45, this becomes 45, and this becomes 45. So they're all equivalent. Right? So that satisfies now that third part. So this is an equivalent, is a proportional relationship. Now let's think about how we could use this. So let's pretend for a second we wanted to then, using this equation, which we just came up with, let's pretend I wanted to figure out, okay, well, what's going to happen when x is 10? Right? So I now know what happens when x is 1, 2, 3, 4. I could just keep taking this table and go 5, 6, 7, 8, all the way down to 10. Right? But if I wanted to figure out 10, or, I mean, think about it, you could easily come up with a problem where you're not going to want to draw out the table. Just make this a really big number, like 814. Right? You're not going to draw it out 814 times. So we're going to use a smaller number like 10, so we're not going to get lost in the math, but keep in mind why this would be a necessary skill to have. So I'm going to take this 10, and since f of x equals 45x, I'm going to take this 10, substitute it here in for x, which means if it's substituted on this side for x, I'm going to substitute it on this side for x. And so this is going to equal 45 times 10. And 45 times 10 is 450. So if I were to take that pattern out all the way to 10, so where x is 10, y would be 450. All right, now let's practice what happens when it's a non-proportional relationship. So the thing that people make the biggest mistake with non-proportional relationships is they think it means that there's not a pattern. And so if you look at this, these are going up by 3, and these are going up by 1. So my change in y is 3, and my change in x is 1. So basically my slope here, right, or my constant rate of change is 3. So that wasn't one of the things that you have to have in order for it to be a proportional relationship. So thinking back, and I'm going to put the slide up in a second, one of the things is it has to pass through 0, 0. So if I take this back to 0, so if I go back 1, these are going up by 3, so it would have to go down by 3. So this would become 0, this would be 6. So it's going to pass through 0, 6. It is not going to pass through 0, 0, which means that it does not satisfy the first part. Okay, now let's look at the second part. Can it be written in the equation of y equals f of x? So if this is, f of x equals kx. So if this is my k, the equation then would be f of x equals 3x. But the problem is that that's not true. So if you look at it, right, if I put a 1 in here for x, this is not 3. If I put a 2 in for x, this is not 6. So it's not satisfying that second part either. Okay, and then the third part is that it would need to be able to be x1 over y1, x2 over y2, right? And so if you look at it here, this is 1/9, 2/12, which can be reduced down to 1/6. So already we know 1/9 and 1/6 are not equivalent. 3/15, which can be reduced down to 1/5. So you got 1/9, 1/6, 1/5. It's not equivalent. If you go the other way, 9 over 1, so this may be easier for some people to see, 9 over 1, which would be 9, 12 over 2, which would be 6, 15 over 3, which would be 5. So you got 9, 6, 5. They're also not equivalent. Okay, so it does not satisfy any of these three. So this one is, well, there is a pattern, and we are going to be able to write a formula for it, and we can get an equation so we could actually predict what's going to happen on the 10th, for the 10th term. It is not proportional, which simply means this is not going to pass through 0, 0. So let's figure out how can we find the equation. So one way, I'm going to talk about 3 different ways that you could figure this out. One way is to take the formula that we used yesterday. I'm going to put it up in a second, which means I need to know the first term, which is 9, and I need to know the common difference, which is 3. And so I'm going to take this formula, which is a to the n equals a1, so that's the first power, plus n minus 1 times the common difference. I'm then going to take this, let's change colors, I've been using green a lot. I'm going to multiply this 3 out, so I got 9 plus 3n minus 3. I then simplify, take these two, put them together, and I get 6 plus 3n, or I could rewrite this as 3n plus 6. Now, the biggest difference between yesterday and today is that instead of calling that n, I'm going to call it x, and instead of calling it y, I'm going to call it f of x. So my equation is going to be f of x equals 3x plus 6. And I'm getting that 3x plus 6 from here. I'm just changing that letter. Instead of calling it n, I'm going to call it x. All right, so this would be one way that you could figure this out. And this will work every time. You just need to know the first term, and you need to know the common difference. Okay? Another way that you can figure it out is I can take this equation, which I used already, so I knew that, remember, I tried to figure out if it was proportional, and I just did what f of x equals 3x, and 3 is coming from here. It's the common difference. And then what I'm going to do is I'm going to take this 1, and I'm going to substitute it in here. So I know that 3 times 1 is 3, but that's not 3. So I now need to either add or subtract something to that 3 to get up to this number. Or in some cases, it's down. So I'm right now at 3 times 1 equals 3, but I want to be at 9, so what number added or subtracted to 3, sorry, I almost dropped it. What number added or subtracted to 3 equals 9, and I would need to add 6. So it becomes 3x plus 6, right, which is the same as what we got over here. Now, let's talk about the third way. The third way to solve this problem is to think about the common difference here, which is 3. So I got f of x equals 3x. Okay, so I'm taking this 3. We found the common difference. I'm putting it here. Then I want to take this back to 0. So when x is 0, what is y? And y, since these are going up by 3, y would be 6. So I'm then going to take this number, and I'm going to put it down here. And since 6 is positive, it becomes positive 6. Either way, no matter how you decide to solve this problem, or using this one, all of them get you to 3x plus 6. Now, this way also works if you come back to that first problem we did. The way we just talked about would work as well. You go back to 0, and this would go back to 0. So you would end up being, okay, the common difference is 45 plus 0. So it's 45x plus 0. So in other words, it is 45x. Right? And if you wanted to use, and I wouldn't necessarily use this formula because I think it's the longer way for a proportional relationship, but you could use this formula and it would work as well. All right, the key thing to keep in mind is that if it is a proportional relationship, you're basically done as soon as you figure out the common difference, right? You just take this, put it in as my k, and I got f of x equals 45x, and I'm done. I don't necessarily have to worry about all this going back to 0 or the an's and the a1's because it's proportional. If it's not proportional, none of those tricks work, and you are going to have to do some work, whether it's this way or this way. All right, I know that that was, even though that was only a couple problems, I know that that was a lot that I'm throwing at you there. We are going to have time in class to practice all this. So make sure that you bring your notes. Make sure you come prepared to work. Thank you for watching the video, and I'll see you in class.